So we're now on to lesson 2, which is about solving equations. So for our warm-up today, and I do want to do this as part of the notes, is so that if you're at home, I'd like you to pause your video and try number 1 and number 2 right now. So if you could pause your video and try those right now, I'd really appreciate it. Hopefully you actually tried these on your own, but I would, if I were solving this, I would cross a line and change the sign. Whoops. Cross a line and change the sign. Try that in a different color. Then I'm going to combine like terms, so I get negative 2m plus negative 4 is equal to 36. Add, of course, the 4 to both sides. I get negative 2m is equal to 40. Divide by negative 2, and I get m is equal to negative 20. Good. Now this other one, what you want to keep in mind right here is this negative out in front. Okay, what I would actually recommend is putting a 1 in there, because you're going to distribute that negative to both of them. So you come up with negative 7 plus 2x, because you're taking a negative times a negative, plus 7 is equal to negative 7. Combine like terms, I get 0. So 2x is equal to negative 7. Divide by 2. X is equal to negative 7/2. Hopefully those two equations will review for you. On number 2, you can leave it as negative 7 over 2, or you can write it as negative 3 1/2, or because it's a terminating decimal, you can also write it as negative 3.5. If it were a repeating decimal, so let's pretend that we got x is equal to, this is a totally different problem, x is equal to negative 1/3, and then we simplify that and we get negative 0.33 ... Go back to this one. That would be your answer. I don't want a repeating decimal as an answer. Good. Okay, let's look at today's, what's going to be happening with this. And it says Joshua is going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50. I like to always underline things that I think are going to be important for a kayak rental. How can Joshua determine the number of hours he can rent a kayak for himself? Describe 2 different options. Now make sure you pay attention to this sign right over here. Okay, try that on your own, please. So we can see that he wants to do it on his own. So if I'm kayaking, that's going to cost me $15 per hour. So I'm going to take $15 times the number of hours, which I don't know, and that's equal to 50, because that's all the more we can spend. So we divide by 15. And when you do that, you get h is equal to 3.3333. And this is one you should know. 0.3 repeating, 0.6 repeating is equal to 2/3. Okay, so I don't want this as my answer. I'm going to go back a step. So I'm going to go 13 1/3 hours. I could go back to this fraction, just dividing them both by 5 and getting 10 over 5. 10 over 3, sorry. 10 over 3. I just erased everything. 50 over 15. So that would be equal to 10 over 3, which would also give me 3 1/3. So how can Joshua determine the number of hours? Well, here's the thing. They're not renting for 1/3 of an hour, so he can go for 3 hours. Okay, so 3 hours. How can he describe 2 different options? So here's one. I set up an equation. The other option would be that we could say, okay, well, I can go and I can say for 1 hour, it cost me $15. 2 hours, I'm up to $30. 3 hours, I'm up to 45 hours. 4 hours, I'm past that. I'm past $50, so that's going to be 60. I only have $50, so I could have made a table. So I could do that also. Okay, next one. Joshua found out that there is a $25 non-refundable equipment fee in addition to the hourly rates. How does this equipment change the mathematics of the situation? Okay, I'm going to give you a second to think. Okay, so our total budget is $50. We're going to have to automatically take off $25. So we only have $25 now in order to figure out how much we can spend. So if I go back to the table method, I can say, hey, 1 hour is 15, 2 hours is 30. I am totally limited to 1 hour. Or I could have said 15h is equal to 25. I could have then divided by 15. So h is equal to 1.6 repeating. So it would have been 1 2/3. So it's still, my answer is 1 hour. Okay, look for relationships. How do the processes you use for parts A and parts B differ? How are they the same? So the way they differ is that in B, you had a flat fee you have to pay. And then you could use the remaining to find out. Whereas in A, there was no flat fee. How are they the same? You had to divide on both. If I'm solving the equation. Okay. And another similarity is that we had to go back to how many hours. So I couldn't do 3 1/3, so it was 3 hours and it was 1 hour. Even though it's 1 2/3, you still had to go back to a whole hour. Good. Now, this is the page in your book, and you would have been doing the work on here. So you have already answered this question and this question and this question. So let's look at this one. Oops. Oops. There it is. How did you determine which operations are needed to solve the problem? Okay, so how did you figure it out? Well, one of the things is you had a total amount here. If I have a total amount, I had to break that up into how many. If we go back to our tape diagrams in 7th grade math, so we had a total of 50. Okay, and we had to break it into how many hours could I actually do it. So that's how I knew I needed to divide. I only had $50 and I had to divide it up by how much each hour was. Okay, so for this particular problem, what I would recommend is that you put it on in your packet, on your workbook page over in the blue space. So we're going to do this one here pretty soon. Number 1, I would do the equation I'm about ready to do right here in the blue stuff. So you can put it right here in the blue stuff. Okay, I'm going to go back to my equation, but you're going to put it in your blue area. So what they want us to actually do here is there is 2 options on how we could do this. Option 1, we're going to call it A, so nobody thinks that one is better than the other, and option B. Now you're going, wait a second, how am I going to do that in my notes? What I would recommend is that what you can do is then divide this. So here can be option A, option B. You know what? Actually, pause this. You could go back 1 page in your workbook and you could put your work on this page. Okay, so because you probably didn't take up a lot of room with problems A, B, and C, so you might want to put this equation right here, even right down here. Okay, you do your work right there. Okay. So when we are looking at this equation, we have 2 different ways we can do this. I'm going to show you both of my ways. I guess I'm going to move that line around. Okay, so I'm going to show 2 different ways that you could do it, and there's more than one way. You want to look at this and look to see what your brain sees. So one of the first ways I could do it is I could move this 8. So if I have this equation, I could start off, I'm going to write the equation out over here again. And I could start off by just adding 8 to both sides. So I have 2 times x plus 4 all over 3 is equal to 40. Now I have division, right? See that division right there? So if I have division, in order to get rid of this 3, I can multiply. So I'm going to multiply both sides by 3. So my 3's here will cancel out, and I'm going to have these 3's cancel out. So then I have left 2 times x plus 4 is equal to 120. Now this is an equation you're used to. You're just going to distribute here. So I have 2x plus 8 is equal to 120. I'm going to subtract 8 from both sides, and I get 2x is equal to 112. Divide by 2, and I get x is equal to 56. Okay, so that's one method. And that's the method that works great. Option B is a different way we can do it. I'm going to rewrite this equation again. I'm going to actually move this. So I'm going to write this equation out again. Now, another thing we can do here is that we could get rid of the fraction. If I could get rid of the fraction, because a lot of times people do not like fractions. So if I could get rid of this fraction right here, and what I can do is I can get rid of it if I take a fraction times that same number, okay, or something that will clear it out, that it's divisible by, I can then cancel it out. Now, if I do that, when we are solving equations, we have to multiply every single term by the same amount. So I'm going to multiply this by 3, but I have to multiply everything else by 3. This is called clearing fractions. Okay, clearing fractions. And it's not a concept that you might have done before. So it's a good one to learn. I can cancel out the 3's. These are both divisible by 3. Then I have 1 times 2. 1 times 2 is 2. Now here, there is a 1 down here. So 1 and 3 don't really cancel, so I'm just going to take 8 times 3 and get 24. Nothing to cancel here with the 3, so I just get a 32. Okay, now this is an equation just like what we were doing before. I'm just going to solve this. So 2x plus 8 minus 24 is equal to 32. Combine like terms here, so I get 2x minus, wouldn't you know I'd have to do that. So 24 minus 8, sorry. Pause. And I get 16 is equal to 32. I'm going to add 16 to both sides. I get 2x is equal to 8. 48 divided by 2. Oops, hold on, something's wrong. I'm guessing you found my mistake. Look right up here. 32 times 3. Is 32 times 3 32? No. So let's erase that. There's my mistake. Okay. So 32 times 3 is 696. Now we're going to still bring down the 96. We're going to subtract 16 from it. And we're going to get 0. We're going to get 80. Divide by 2, and I get 40. Hey, these have to come out to be the same. So I made another mistake. Let me go work. Did you find my mistake? I'm not trying to do error analysis, but boy, this is great. Okay, so look what I did. I added 16 here. And I subtracted it here. You do the same thing on both sides. So I needed to add 16, and when I do that, it's all going to work out. So I add 16, and I get 112. 112 divided by 2, we already know, is going to be 56. So the whole point was to try to show you that you could do it 2 different ways. You could do option A, where you add 8, then get rid of then you have division, so you multiply, okay, and go on. Here, we can get rid of the fractions first. We're going to clear fractions. To clear fractions, we're going to multiply everything through by that common denominator. Both will get you the same answer. Unfortunately, it turned out to be, let's see if we can actually find Jill's mistakes, and it was error analysis. So let's go to your problem right here. So on this one, I could do option A. I could start by moving the 4. I could remove the 4 from both sides. So I'm going to subtract 4. Let's make sure I don't make that mistake again. Be more careful in my work. Subtract 4 from both sides. Subtract 4 from both sides, and I get 3x minus 1 over 2 is equal to 5. I then have division, so I can multiply both sides by 2. And I get 3x minus 1 over 2 is equal to 10. I have division, so it should be gone. Wow, this is another reason you shouldn't do math too late at night. You make more mistakes. Okay, so now we're going to add 1 to both sides. We get 3x is equal to 11, divide by 3, and I get x is equal to 11 thirds. Now, 11 thirds, if you put it into your calculator, is going to be a repeating decimal because it has a denominator of 3. So there's our answer. I will take that one. The other way we can do is we can start off by actually multiplying through by the common denominator. So we can multiply every single term by 2. When I do that, I get 8. Hey, you know what? That's lazy work. Let me write that equation out. Sorry, hold on. So in this one, I can clear the fraction. To clear the fraction, let's look at steps for that. To clear fractions, because you're going to have some in your homework that you're going to want to make sure you actually clear the fractions first. First, you're going to find the common denominator. Second, you're going to multiply every single term. Every term by the common denominator. Every single term gets multiplied by the common denominator. Okay? Every single term gets multiplied by the common denominator. Every single term. Because what you're essentially doing is that you're multiplying one side by 2 and the other side by 2, because you always have to do the same thing on both sides. Well, when I do that, I would actually then distribute the 2 to both terms. Well, if I do that, that means I would distribute it. So I just like to do every term. It just saves me one little step. Okay, so that means I get 8 because there's nothing to cancel here. Now here, there is something to cancel. I can take out a 2. So therefore I have 3x minus 1 is equal to 18. Combine like terms, solve it like you've been solving, no problem there. Subtract 7, and I get 3x is equal to 11. Divide it by 3, and I get x is equal to 11/3. And that's a fine and dandy answer, actually, in the math world, and as you go up, that's the answer we want, is 11/3. If I'm going to go measure cups of flour, though, I'm going to do it as 3 2/3. Okay, never do we want a repeating decimal. Okay, let's look at the next question that we have on your paper. How can you check that the value of the variable makes the equation true? How can I check to see if it works? Well, what we can do is that we can plug in, we plug the answer into the original equation. Okay, so I would take my answer of 11/3 and I would plug it in. So my original equation is 4 plus 3 times x, we're going to plug that in, minus 1 all over 2 is equal to 9. Now I'm going to take and plug in my 11/3. So I have 4. Oops, I'm going to plug in my 11/3 right here. Okay, so then I get 4 plus, well, my 3's dropped, so I have 11 minus 1 all over 2. And I'm just going to work on this side because my whole point is I want this side to equal this side. Okay, so I'm going to solve this equation. I'm going to just simplify. This is an expression now. I'm going to simplify this expression. So I have 4 plus 11 minus 1 is 10 over 2. So that's 4 plus 5. Does that give me 9? Yes, it does. So that's how I just checked if my answer was right. I take and plug the answer into the original equation is what that says right there, if you're wondering. Plug the answer into the original equation. Okay, I'm messing everything up. We're going to just move on. Okay. Now the next problem we're going to do is that we're going to just do it right in your workbook as your next one, because we're going to do a couple of these. We're going to start with the one that's in your workbook. Shoot. Oh, no, I'm good. Sorry. Okay. So I'm going to start with the one in your workbook. So let's talk for a second about consecutive integers. What does it mean if something is a consecutive integer? So if you ever get stuck on this and you're not sure what to do, then just pick an integer. Okay, so I'm going to pick 12. What is the next consecutive integer after 12? Well, consecutive means one right after the other. So my next one is 13. What's my next one? 14. 15. Okay, you get the idea. But a consecutive integer. Now, the reason I show this method right here is if you ever forget what this means, pick a number and find its consecutive integer. Okay, and we're going to use this to figure out what happens. So what we have to do is we have to have 3 odd. That's going to be important. 3 odd. Okay, so let's do this again. Pick an odd number. 13. Okay, nope, I'm going to need that space, so I'm not going to do that. 13, that's an odd number. What is the next odd number after the consecutive one? Right, 15. What's the next one? 17. Okay, so the sum of 3 consecutive odd integers is 57. So I need to symbolize those integers. If I say x is equal to the first consecutive odd, okay, what is that word? Consecutive odd. Okay, so let's play that, pretend like that's 13. So what do I do to 13 to get to 15? What do? I add 2, right? So if I want my second consecutive odd, then I'm just going to add 2 to the first one. What's my first one? X. So my second one is x plus 2. Then if I want to get my third consecutive odd, what do I do to my first one to get to my fourth one? I can't go off this one. I have to go from my first one because that's x. Everything has to be based on x. So what do I do from 13 to 17? I'm going to add 4. That's going to be my third consecutive odd. Okay, so that's what I need to set up first. My first one's going to be x, x plus 2, and x plus 4. If you don't set this up, in all my years of teaching, people who don't set this up usually get it wrong. Take the time to do it. Okay, so now let's look at the equation. We need a sum. What does sum mean? I'm going to add. So I'm going to take all 3 of these, and I'm going to add them because I want the first one, which is x, plus the second one, which is x plus 2, which is the third one, which is x plus 4. Okay, so what I'm doing is taking the first plus the second plus the third to get my total. But my first one is x, my second one is x plus 2, and my third one is x plus 4. Do I need the parentheses? No. That's just for emphasis. So now we're going to solve this equation. I'm going to pause it. You do this, you solve, go. So hopefully you also got that x was equal to 16. You combine like terms, and you got 3x. 2 plus 4, also like terms. You combine those and you get 6. We're going to subtract 6 from both sides. We divide by 3. We get x is equal to 17. That's not our answer. That is our first integer, is 17. Now here's the other thing. It's an integer. So if you come up with a decimal or a fraction, you did something wrong. It has to be an integer, positive or negative. Your second one obviously is going to be 2 more than that, and also it's consecutive, so it's 19. Oops, I'm going to write it up here so you can actually see what I'm doing. Okay, so 19 is my second one. What's my third one? Right, 21. And didn't I add 4 to 17 in order to get 21? Yes, I did. Okay, I'm going to